VSEPR theory helps us predict the 3D shapes of molecules. It is based on the idea that electron pairs around a central atom repel each other and stay as far apart as possible to minimize repulsion. To find a molecule's shape, we first calculate the steric number. This is simply the sum of the number of lone pairs on the central atom and the number of other atoms bonded to it. When the steric number is 2, the electron pairs move to opposite sides. This results in a linear geometry with a bond angle of exactly 180 degrees, as seen in beryllium chloride. A steric number of 3 creates a trigonal planar geometry. The 3 bonding regions are spaced 120 degrees apart within a single flat plane to maximize their distance. With a steric number of 4, the molecule adopts a tetrahedral shape. This 3D arrangement allows for electron pairs to be separated by an angle of 109.5 degrees. While the steric number defines the electron geometry, the molecular shape depends on lone pairs. Lone pairs occupy more space than bonding pairs, which slightly pushes the bonds closer together. In ammonia, the steric number is 4, but one position is a lone pair. This changes the tetrahedral electron geometry into a trigonal pyramidal molecular shape with a reduced angle of 107 degrees. Water also has a steric number of 4, but with 2 lone pairs. These 2 regions of high repulsion compress the bond angle even further to 104.5 degrees, resulting in a bent molecular geometry. A steric number of 5 leads to a trigonal bipyramidal shape. This is unique because it has 2 distinct bond angles, 90 degrees between axial atoms and 120 degrees between equatorial atoms. Finally, a steric number of 6 results in an octahedral geometry. All 6 positions are equivalent, and every bond angle is exactly 90 degrees, forming a highly symmetrical structure. In summary, the steric number is the key to identifying molecular shapes. By counting bonds and lone pairs, you can determine the electron arrangement and the resulting bond angles for any simple molecule. You have now mastered the basics of steric numbers and molecular geometry. Practice calculating these values to predict the behavior of different chemical compounds. Generated by Vision Solve AI.